Let's get started. Happy Friday, everyone. It's great to welcome you all to another episode of the YugabyteDB Friday Tech Talks series. I'm Kannan Muthukkaruppan, co-founder, one of the co-founders at Yugabyte, and it's my pleasure to welcome. Let's get started. Happy Friday, everyone. It's great to welcome. Sorry, I had audio on from the LinkedIn feed, so it started echoing. Yeah. So my pleasure to welcome Amit Jambure today, who's going to talk about the area of how to bulk load data into YugabyteDB's YSQL API. So over to you, Amit. Why don't you start by introducing yourself as well and then get into the topic?
Yes, thanks, Kannan. Thanks. Hi, I'm Amit Jambure. I am a software engineer in Yugabyte's Voyager team. I joined Yugabyte for more than 1 year now. Should we start, Kannan?
Yes, please go ahead.
Yeah, let's start. So in engineering, everything starts with a problem. So let's first look at the problem statement with which this talk is concerned. Let's say you have your data sitting in local files. The files are in either CSV or PostgreSQL's text format, and you want to load it in YugabyteDB database, and you want to load it fast. If these files are smaller, then this is not really a problem. You can do it very trivially. But as soon as you enter into the territory of multiple terabytes of this data, then this problem can quickly get tricky, and you need fast tools to ingest the data. And that's where this talk comes into the play. Okay, so YugabyteDB provides two APIs. One is PostgreSQL compatible YSQL API, and another one is the Cassandra compatible YSQL API. There is a separate talk scheduled for bulk loading data using YSQL. This talk will be only concerned with the YSQL API, that is the PostgreSQL compatible API. Okay. Even in YSQL, there are two ways to bulk load the data. One is using the database's built-in copy command, and another one is a database migration tool that is developed by Yugabyte, and the name of that tool is Voyager. Let's get started looking into the specifics. First, with the copy command. Now, as I said, YugabyteDB's YSQL API is exactly the same as PostgreSQL API. So PostgreSQL provides the copy command for bulk data loading, and so does the YugabyteDB. So in its simplest form, this is how the copy command looks like. All you have to tell the copy command is from where to read the data. Sorry. Yeah. All you have to tell the copy command is the from where to read the data and where to put the data. Okay. Then the copy command will load the data from the file into the table. And once the transfer is complete, it will return how many number of rows were ingested in the foo table. Now, there are some aspects of that are not immediately visible from this command. And the first thing is that this copy command supports importing the data from either CSV format or PostgreSQL's native text format. We'll take a look at the differences between these two formats. But here, the default format is PostgreSQL's text format. So this file must be in text format. Then the second thing that you need to know is if the table foo already had some data, then that won't be deleted or truncated. Okay, the entire contents of this file will be inserted or appended into this table. Okay, so no deletion is happening during copy. And another important thing is, let's say if this foo table had 4 columns, then your data file must also contain the 4 columns, and the types of those columns must also match. Otherwise, copy command will complain. But there are certain cases where the order of columns might be different in the data file, or the data file might have fewer number of columns than the table. Okay, in that case, what you can do is use this alternative syntax, where you explicitly list the names of attributes for which you are loading the data. Okay, so this is the simplest form of the copy command.
And
Okay.
Amit,
Now,
is it fair to say that in some of these respects, the copy command behaves exactly the same in Yugabyte as it does in vanilla Postgres?
Yes. So almost always you can start considering that it behaves exactly like PostgreSQL. There are only one place where it differs. We'll get into that. Otherwise, it's the same as PostgreSQL.
Thank you.
Okay. Yeah. So the next thing is people often confuse between the copy command and /copy command. So I thought we'll quickly clarify the difference here only. So whenever you enter any command that begins with a backslash on YSQL sh, then this is called as a meta command. And this kind of command is interpreted by the YSQL sh itself, the shell itself. Okay. So let's take the normal copy command first. Let's say you fire a YSQL sh, you connect to the target database, and then you fire this command, copy foo from the file name. Because this command is not starting with a backslash, YSQL sh directly sends the same command to the server. And now server tries to look for that file in its own file system. Okay. Now this will work only when you started YSQL sh on the server itself, which is not usually the case, right? In most of the cases, your client machine is going to be different from the server machine. So that's where the backslash copy comes into the play. And how does this one differs? You enter the syntax, the arguments are same as copy command, only the difference is this extra backslash. After seeing this backslash, YSQL knows that this is a meta command and it has to parse the command. Okay, when it parses the command, it realizes that this is a copy command and it extracts the file name and opens the file from the local disk, that is the client's disk. Okay, and then it will send this copy foo from STDIN. This is a slightly different command from the one that was entered on the command line. Okay, and the YSQL sh and the database driver, they will work together to somehow map the contents of this file to this STDIN. So whenever the target server is reading the data for this bulk loading, it is reading from the client's file. Okay. So I hope this clarifies the difference between copy command and /copy command. So here is a quick example of the copy from STDIN command that we saw here. So I have created a simple table which has 4 columns, 1 integer, 2 text, and 1 Boolean column. And then we enter copy foo from STDIN. Then this YSQL sh start asking for the data on STDIN. Here, what we have to do is provide 1 row per line. Okay, and the columns of the row are separated by the tab character. Now, so this first row is the simplest one. How would you specify if the column itself contains the tab character? Then you would write it as a \t. That is two characters. You represent tab as \t. Similarly, if you want to include a new line inside the value of a field, you specify it as a \n. Okay. Now, and let's say if you want a null value for any column, you specify it as \N. Remember, \small n is for new line, \N alone is for null value. And once you enter all the rows, when you enter \dot, that is signaled as end of data. And the copy command will take the input and insert it in the table. So take a look at it, how this data got inserted. first row is the simplest one, no magic happening there. In the second row, the tab character is included. Here, the new line character is there. And in the third row, you can see that S1 and S2 are null. Okay, let's move on. So text format is PostgreSQL's alternative to CSV. Now, in some sense, the text format is very well specified and it is simpler than CSV. If we look in the wild, different applications provide different kinds of CSV files. So CSV is more of a guideline than a standard. So if you look at the differences between CSV and text file, in CSV, a single row can span multiple lines. Imagine one JSON column, one column containing pretty formatted JSON value. Such a row can span like hundreds of lines in the file. On the other hand, in text files, irrespective of size, every row is one line. The null values, for example, take a look at here. For column 2, null value is specified by not providing any value between the two commas. Now, remember that you shouldn't put any space here because that space will be significant and that space will be treated as a value. Here, you have to provide the successive commas to interpret it as a null character. On the other hand, in text format, you just specify the \N. That is, the text format is much more explicit about the null values. The default delimiter in comma is in CSV is comma. In text file, it is tab. Now, in CSV, there can be pipe is used as delimiter or tab is also used as delimiter. So if tab delimiter is used, then the file looks very similar to text format. So you can easily get confused. But let's say this comma, the delimiter value, if it appears inside the value itself, then how would you handle it? In that case, you have to include a single or double quotes around the value. Okay, and then you again run into a situation where the quote character itself can appear inside the string. In that case, you have to escape that quote character inside the value. But no such tricky quotations and escape is present in text format because we are explicitly writing the tab as \T and new lines as /n. Okay. So what we earlier saw was the simplest form of copy command, that is copy table name and data file name. But you can tweak the behavior of copy command by providing a bunch of options. As I had said, YSQL is nothing but PostgreSQL. So basically, YugabyteDB reuses the PostgreSQL's query layer. And Postgres provides total 11 options for the copy command, out of which 8 options are related to copy from command. There are 3 additional options which are related to only copy to command. Okay, that is not relevant for this presentation. All those 8 options are related to describing the contents of this file. Okay, and out of those 8 options, 4 are related to describing the CSV format only. Okay, then YugabyteDB has enhanced the copy command to include 4 more options. So we'll take a look at them. So the simplest option is that tells what is the format of this file. So because copy command provides supports 2 formats, CSV and text file, you can specify the format of this file using the format option. The default value is text, and that's why in the earlier example, we didn't provide any because our file was also in text format. But if you are importing a CSV file, you will have to mention the format and format CSV option. Rather than just listing or explaining these arguments, let's take a look at an example file. Here I have one example books.data file. It has one header row. Okay, then pipe. This is a CSV file, but pipe is used as delimiter, not comma. Okay, here is one value where the delimiter itself is appearing inside the value. Okay, in that case, we have to include this value inside a single quotes. Okay. In some cases, it is also possible that double quotes are used for quotation. Okay. Then here is an example where the quote character itself appear inside the value. In that case, we have escaped the value, escaped the quote character by using \/ character. In some cases, one might also use the same single quote character in quick succession to represent the escaping. And here the null value is represented using a string nil. Okay, some formats can use NULL to represent null, or they can simply have nothing between the two delimiters to represent null. Okay, how will we import this file? Then you have to provide the enhanced copy command. So table name, file name, and these are the bunch of options. You specify the format as CSV. The delimiter is used as pipe. Yes, our file has header, and the null was represented using the string nil, and the quote character is a single quote. Now this is funny. Why I have given 4 single quotes? Basically, I'll leave it as exercise, figuring that out. Then the escape character is represented using \. And once we run this copy command, 3 records will be imported. You can see that the pipe character is included as a value. Then the single quote is included as value. Null value is correctly interpreted. Okay. Let's take a look.
One question, but I think you clarified some of it. I mean, the question was around how to treat null values, and and here you give an example of, like, if you don't like the default of /n, then you can use this kind of an override using some of the options.
Yeah.
Another question was, what about special characters if we have in the data set? But I'm guessing that's kind of what you answered already.
So, yeah, this is the file is treated as Unicode. So if it is interpreted, it can be interpreted using Unicode. That's fine.
Got it. Thank you.
Okay. Now let's quickly take a look at the 4 additional options that were added by the Yugabyte. Let's start with the simplest one. Disable foreign key checks. Here is the thing. The lesser work that we perform during data ingestion, the faster the data load is going to happen. Okay, so because when the data load is happening with a sane snapshot of the data and no concurrent load is going on, in that case, you can basically remove some safeguards from the database to reduce the work, and that way speed up the data load. So in that spirit, the first option is the disable foreign key checks. If you do not do foreign key checks, the data load is going to be faster. Then there is another replace option. Now, replace options enables what is called as upsert mode. Whenever copy command is inserting one row in the database, first it has to check whether that primary key already exists in the database. So that's a read operation. And only when that row, that primary key doesn't exist, it will proceed to inserting that particular row. But if you are bulk loading the data in the initial phase, you can do away with that check. Instead, you can ask copy command to simply start loading the data without checking for the existence of the key. Okay, and even if the key already exists, just overwrite it. That upsert mode can be enabled using the replace option. With the skip option, okay, we'll come to skip option after the Rosebud transaction. Yeah,
one way to think about this mode is kind of the insert, what you could do with insert on conflict, meaning if you're attempting to do an insert, but if you found that the row already exists, you want to silently kind of uptake the new value. So this is a very useful mode if your app, what it wants is an upsert behavior. Maybe your file this time has actually new values for the other columns, the non-primary key columns, and maybe you want to accept those new values and just kind of be in overwrite mode. So it's a helpful option to consider.
Yeah. So given that this command is usually used on empty tables, it is almost like a very safe option in that case. So let's go to the rows per transaction. And here is one difference from the Postgres implementation. In Postgres, this entire copy command is one transaction. So even if you import 1 terabyte file, and if at the last record the insert fails for that record, then it will roll back the entire thing. Okay, but that's not the case with Yugabyte. In implementing distributed transactions. So here it proceeds in chunks. Okay, for example, by default, the value of rows per transaction is 20,000. And if you import a file containing 100K records, then it will first import first 20K records in one transaction. Once that is complete, then it will proceed to the next 20K records. That means, let's say if the command fails at 50,000 row, then that means your 2 batches are already inserted. Okay, and only at the 3rd batch it failed. That means when the command fails, you will see 40,000 rows in the database, and that is different from the Postgres implementation. Let's say when you fix the issue and you want to resume the bulk ingestion, you wouldn't want to insert the 40K rows that you have already inserted, right? In that case, the skip command comes into play, where you can say that skip 40,000 because I have already inserted the first 40K records. You just start with the next one. So that's where the skip command comes into the play. I have one quick example showing that thing.
But
I have one, yeah.
There's one more question, by the way, that's come in, which is like, do you only support importing from CSV files, or can we do any type of file like Excel, etc.?
Right now, it's just like PostgreSQL. It supports only CSV and text format.
And in some sense, when you have data in an Excel, you can do it in 2 steps. You can first export it out into a CSV format, and then do it in the second step. Keep going. Yeah.
Correct. So here is the example. I have one very trivial table which has one string, integer and string column, and this is the sample data. Take a look at this 5th row. It has one error. The column expects integer, and I have added x as it's a character value. When I give this copy command, run the copy command with this file, it is going to fail at this line. Okay. Now let's see what will happen if we use the rows per transaction as 2. Okay. Still the copy command fails, but 4 rows are already inserted. Let's see how does that happen. These first 2 rows will be inserted as part of first transaction. These next 2 records are added in the subsequent transaction, and during the 3rd transaction it fails. Okay, and that's where the copy command exits, and at that point the 4 rows are already inserted. That's what you're seeing here. At this point you have 2 options. Either let's say the first thing is that you have to fix this file. Let's say you open this file and add 5 here instead of x. And after this point, you have 2 options. Either you skip these 4 columns and insert only the remaining portion where only the 4 columns, 4 rows will be inserted, or you can enable the replace mode where it will simply overwrite all these existing values, and it will again insert the entire 8 rows batch. Okay, so that's what is shown in this example. So after fixing the file, if you try to copy the same file again, then the command is going to fail with this duplicate primary key error, because you already have some data in it. So in that case, you should either use skip 4 option that will result in inserting the remaining 4 rows, or you use the upsert mode, and in that case, all 8 rows will be inserted. Okay.
So Amit, just as a time check, we have about 5 minutes, but then I think I would say we can go over by 7-8 minutes. So I think let's try to.
Okay.
We have about 10-12 minutes.
Yes. Okay. This is the last slide in the copy section. So here are some suggestions to speed up your data ingestion. So the first thing is you should enable packed column feature. There is a separate YFTT session on this one. Basically, this is a new persistent storage format that is way faster than the earlier ones. Then, as I had said earlier, the lesser the work copy command is performing, the faster the ingestion. And that's why you should create the indexes only after bulk loading the data. Then the next thing is disable the foreign key checks by using the disable FK checks option, or you can also disable foreign key checks using this session variable. Similarly, enable the upsert mode by using the replace option. Then you should choose correct value for the rows per transaction. I have provided one link here, which is a blog from our developer advocate, Frank Pacho, who runs one experiment to find out the optimal size of the rows per transaction, because this depends on the cluster configuration. It is set to default 20K, but your optimal value will be somewhere around 20K itself. Okay. Then the last option is while creating the table, you should pre-create some number of tablets. This will avoid the extra work that goes into whenever the tablet fills up, the DB needs to split it into smaller tablets. All that work can be avoided if you know that your data is large. You can pre-create the number of tablets. Now, how many number of tablets? That's a difficult question. And that's why I have provided another blog from the same Frank Pacho, who has in detail explained how to choose the number of tablets. Okay.
And I
so
just to add
give,
that
yeah.
For hash partition tables, Yugabyte itself pre-creates a certain number of tablets, but this is more, I would call it an advanced knob. If and I think by default, like on 16-core machines, Yugabyte will create about 8 tablets per server. So if you have a 10-node cluster, by default itself, Yugabyte will create about 80 tablets. But this gives you a finer and more advanced level of control if you want to avoid this. I'll add one more suggestion, which is like if you're doing a fresh data load into an empty set of tables, which also need an index, one strategy is to load the data first and then create your indexes, as opposed to having so that's another probably suggestion for faster data loading.
Yeah, that's what I included here in the second option. Create indexes only after loading the data. Yeah. Okay. So this is one quick example on a 36-core machine with 72 GB of memory, 3-node cluster using YugabyteDB 2.17. Inserting 900 million rows took 4.5 hours. Okay, that's like 56K rows per second. And we'll see, just remember this number, 56K rows and 4.5 hours. Okay. Now, the next option is the Voyager. Now, what is Voyager? Voyager is a database migration tool from Yugabyte. Okay. It supports both schema migration and data migration from Postgres, MySQL, and Oracle. Okay. Now, why I'm bringing in a database migration tool in this discussion? Because we are interested in the data migration capabilities of this tool. Imagine during database migration, you dump like a 5 terabyte or 10 terabyte worth of source database in local file system, and then you have to load that data. So faster data ingestion is like a bread and butter of a database migration tool. When you install Voyager, you get a single statically linked executable file, and the name of the file is yb-voyager, and it sits in user local bin file. Okay, and the bulk data loading capabilities that I talked about, those are exposed using yb-voyager's import data file subcommand. Okay, and internally Voyager is also going to using the same copy command. But the secret sauce here is Voyager will break the input file into smaller chunks, and it will concurrently load those chunks. So it can throw in many parallel copy commands on the server, so that it can even saturate the target cluster. Okay, and that's why this one is very faster. So what do we get when we use Voyager? First, it is fast. It can be 7x, but this number is just an example. It depends on how much parallelism your cluster can afford. It can consume huge clusters as well. It's resumable. That means, let's say if your table was 1 terabyte and during 900 GB, there was some bad row, and because of which the command failed. So when you fix the data and you restart, it will start where it left off, right? Then progress reporting. The copy command will come back only when the data ingestion is done. But Voyager will continuously keep on telling you the progress that it has completed. And with the recent release, Voyager has also supports importing the files from the S3 itself. Let's say if your CSV file or text file is present in an S3 bucket, you can directly mention the S3 bucket address to the Voyager, and it will correctly stream without loading the entire file in local disk first. Okay, so the local disk requirement is very low in this case. How do you install Voyager? We provide all sorts of ways using yum, apt, brew, or docker. So just follow this link and you should have the install instruction. My favorite one is installing from the source. You just clone the Voyager repository and just run one installer script, and you should have a running environment. By the way, Voyager is open source.
Yeah, by the way, two comments. One on the previous slide. Yeah, I really love the resume feature. I mean, it's like really, really handy. And it's done in an innovative way, like how you keep checkpoints in the target database itself up to how much the progress has been. And points are kept in a transactionally consistent manner. Really cool. And on I think I had one more thought, which is like, although you can yum install this anywhere, right? Maybe a good suggestion is to still keep it close to where your database is and not like, a different region or a different data center. The closer you are to the target database, the better throughput you're going to get. Yes, correct. That's right. Okay, next. So Voyager is a single standalone executable. It's a native program. It's not a script. Okay, and it has these subcommands: import data file, and all the information that is required to import the files is provided as a CLI options. You can see that there are lots of CLI options, but if you group them in some logical groups, they are fairly straightforward. Because you are going to import it in the Yugabyte database, you need to provide all the connection details, the host, port, username, password, right? Then you need to tell where are your files. Now, the simplest case would have been just take the file path, the full file path, and take the table name, that import the data from this file to this table. But we also wanted to support a case where you want to import multiple data files in a single command execution, and that's why you basically provide the parent directory path in the data directory, and then you provide something called as file table map. It's a comma separated string, and each element is like a file name : table name. Okay, so basically this file from data directory should go to that table. So basically the combination of these two options allow you to import multiple files in a single command execution. Then there are some bunch of commands regarding telling the contents of the file. And by now you must be familiar with these names. Voyager is going to just take the values of these CLI options and use it to form the copy statement. Now there is in order to support the resumability feature, Voyager needs to keep some state in local file system, and so that basically a workspace directory, and you specify the name of that directory using the export dir option. Now, why it is called as export dir? Well, because this Voyager is a database migration tool, and in a database migration workflow,
the word export makes sense, but we continued to use the same for this purpose as well. Then there are some bunch of options that control the import operation itself. For example, parallel jobs that decides how many chunks that you can import concurrently. Yeah, the recommended value is, let's say if your cluster has 100 cores, then you should specify 50 as parallel jobs. Okay, then the start clean is like, let's say basically you want to resume restart the entire import operation again, then you can use the start clean option. Batch size is basically how many rows you should include in one copy operation. The default size is same as the rows per transaction, that is 20K. So this is an example invocation of the import data file command execution. Here we have imported the same file that we saw earlier imported in the copy command. Okay, just note some feature that we are executing yb-voyager executable and subcommands are import data file. The parallel jobs is 48. The format is CSV. Delimiter is used as pipe, and the file is line item.csv file from this directory, data/small data, and the content should go in the line item table. Okay, and there are a bunch of options for connection details. And earlier the copy command had completed the job in 4 or 30 minutes, and here Voyager completes it in 40 minutes, and the throughput is roughly 375K rows per second. Okay, that means the point is Voyager is way faster than copy command.
Yeah,
I think yeah.
Yeah, like if maybe you could stay like it's it's a interesting use of how it uses copy command underneath, but builds all this parallel sophistication and throttling all that on top. One question on that topic is, suppose I have lots of large tables, then doing the parallelism within one table and then finishing up one table, moving to the next table, all that makes sense. But assume I have hundreds of small tables. Today, do we parallelize multiple tables at the same time, or do we generally still finish one table at a time?
So multiple tables can be imported parallelly.
Okay.
So let's say there are like you specify that you can submit at a time 20 batches to the server, and you have one table which has only like 15K records. That means it will occupy only one batch. Okay, so we take we submit that batch and we immediately proceed to the next file.
Makes sense. So the things running in parallel can belong to different tables. That's great.
Yeah, that's right.
There was one other question. When you do use the replace option, does it tell you how many rows were replaced versus how many rows were inserted fresh?
No.
Yeah.
So towards the end, it will tell you the entire. So almost always, if you use replace option, then and the copy command is successful, that means the entire file got inserted. So the return value will be same as the number of rows in the file.
Yeah, unfortunately, we don't give you that distinction of how many were actually the new rows, and in fact, some of it is the implementation tries to use a fast path to not maintain that statistic. So that's the reason.
Yeah, the whole point of that option was to not to look for primary keys in the first place. Yeah.
Let's go to the last slide, and I think any closing comments. Wanted to appreciate all of you that joined us today. I know we were a little bit over time, but there was a lot of valuable information Amit provided. I learned a lot during the talk. Thank you so much, Amit, for this presentation. Thanks everyone for joining. Amit, over to you for closing thoughts also.
Thanks for having me, Kannan, here. And if you guys have any question, just join the YFTT channel on the community Slack group, and I'll be happy to answer them.
You all have a great rest of the day and weekend. Thank you.